Hey folks, we all know that writing the perfect pull request is impossible. Every project is different, every context is different, but there are a lot of key aspects that are more or less the same for all the projects. So in today's video, we're going to read together a great article, let me show you, about all the types of problematic pull requests, and we will get hopefully some insights on how to write some great pull requests. So let's get started. The 11 types of toxic pull requests according to a lot of code branches. I already know the, the big picture here is beautiful. So let's get started. In word of software delivery, pull requests are at the heart of collaboration between many engineering teams. Yet, while PRs are pivotal from ensuring code quality and fostering collective inputs, they have also become the leading bottlenecks in development workflows. Oh, yeah, I saw this so many times. The thing is, pull requests are really good because you cannot live without them, but sometimes can become really frustrating to deal with a lot of PRs. Even you know, the bigger the team, the more problem you will have in having tons of pull requests, merge conflicts, and so on. But let's go on. Poorly crafted or mismanaged pull requests can spell disaster for productivity. Yes, sometimes people open just random PRs and they say fixed stuff. Okay, you fixed what? And you just don't add descriptions, you don't add useful information on what thing you were trying to fix. Sometimes can be a real mess, but the good news is that you can enforce stuff, right? For example, if you are using GitHub, you can enforce the title of the PR to follow some regex or some patterns. Same applies for the commits. Same applies for the PR description. So don't trust humans, trust automation. So even if can be a little bit frustrating when you start a new project and you see, oh, okay, there are a lot of things that I have to comply with, but the more you're used to them, the better it would be for the entire team. So okay, engineering metrics benchmark study. I will read it later. Sounds interesting. Analyzed work of 2000 apps. Good. And millions of code branches. Okay. The average cycle time for a piece of work from the first commit to the deployment is 7 days. Half of all the PRs are idle. Yeah, exactly. That's exactly what they were saying. So no one is actually working on them for at least 50% of their lifespan. Yeah. Cycle time and idle time doubled for pull request of plus 200 lines of code compared to pull requests with 100 lines of code. Yeah, definitely. This is something really important that I learned from my manager in my last company. Keep your fucking PR as small as possible. If you have to create two, three classes or whatever, if you have to do a big task and you clearly see that you can split that task into multiple sections, just create multiple PRs. That's way easier to review, right? So keep your PR as small as it can be. So, having pinpointed this significant dip in development productivity, researchers have uncovered the root of this subpar performance indicators. Oh, cannot wait for it. Based on qualitative and quantitative analysis, developers and data scientists have identified 4 primary issues in PR management and 11 common types of pull requests that are particularly detrimental, okay, didn't know that term, to workflow efficiency. Oh, let's see. 4 root problems. Beautiful. Many organizations have no formal process for getting pull requests assigned. Yes, definitely. Ownership. This is exactly the concept of ownership. So please, as soon as you can, create this kind of process. No standardization or best practices guidance for the PR size. That's what we were talking about before. So, as a rule of thumb, the smaller the PR, the better it is. Of course, that's not always possible. Sometimes you just are making a big refactor, or sometimes you are just implementing something that will broke other stuff. So sometimes it's okay to deal with big-ish PRs, but at least you need to have some best practice for saying, hey, if you're making this PR, maybe can be structured slightly differently, or maybe you can have 2 PRs, 3 PRs, or whatever. Let's go to the third one. Teams treat all PRs with equal importance despite their different risk levels. Yes, that's definitely one key point. The thing is, PR generally is a change into the code that wants to go, I don't know, maybe overproduction, right? The thing is, not all the changes are equal. Maybe you're changing the position of a button, that's all good. Maybe you're changing a validation on the schema, on the backend, sorry. Maybe you're changing the schema of your database. Maybe you're changing a business logic. Maybe you're changing your tasks. Maybe you're changing something from an architectural point of view. They are all changes, but they have different impacts and of course different risks associated with them. So in theory you should have a way to say, hey, you changed this button position or the button background color, auto approval, never mind. You changed the schema or whatever, okay, in this case let's put this in a different environment first. Let's try this stuff a little bit more. So, alright, number 4, lack of visibility into PR context or how long it will take to review. Yes, until it's open. Definitely. So, all 4 cases, these 4 root problems are really important. I see that a few are more important than others. I see a couple of other root problems, but maybe we will find something more in the article. So let's continue. With root problems of poor PRs identified, engineers could now work on solutions to this massive hurdle in the development workflows. One of the most promising of these fixes has come in the form of continuous merge, the practice of automating the classification of pull requests in order to optimize the path to merge. Yeah, that's more or less what we were saying before. The 11 types of toxic pull requests. Yeah, let's see it. Alright, small PR purgatory. Pull requests that languish in inboxes for days are all too familiar. What's worse is when these requests are merely for documentation changes. Yeah. Quick updates get sidetracked, delayed, even the simplest of tasks. My documentation changing. Okay, that's really fun. That's really fun. Pull requests with outdated code, submitting a PR to a deprecated API. That's not just redundant, but it also signifies a lot of synchronicity with the system's current state. Yeah, definitely. These types of PR are simply clutter, causing unnecessary overhead. Yeah, in my last company, I saw a couple of them. I also brought a couple of them. So every engineer is a bad engineer, right? But yeah, this is just overhead for the entire team. No matter what, if you have a code that is dying or that is deprecated, don't change it. Unless it is for migration purposes, security purposes, even if you have a deprecated API that someone is using it, if you find a security vulnerability, then it's probably worth to fix it, even if it's deprecated. But of course, this depends a lot on the context. Then, pull requests that require documentation research. That's interesting. Without proper documentation are like entering a room blindfolded. Without clear documentation, reviewers are left guessing the intent, leading to a whiplash and context switching. Yeah, definitely. So every time you write a PR, of course, you have to write what that PR does, how is that PR interacting with the code and the system overall. So high risk PR without adequate review support. Okay. A super large, potentially hazardous pull request with only one reviewer? This is the ticking time bomb. Yes. Give it. I saw so many of this. Okay. I will not lie. This happens all the time. Given the height impact changes, this PR should ideally have multiple sets of eyes to ensure accuracy and security. Yeah. The thing is, as a rule of thumb, the bigger the PR, the more impact, either in good or in bad, or the more risk you see associated with a PR, the more complex it is. First of all, split it if you can. Second thing, ask for a review from, I don't want to say the whole team, but at least 2, 3, 4 people, maybe with different backgrounds. Maybe those people can spot different issues, different potential issues in different parts of the PR. So as many people invest their time in reviewing that PR, the better will become. Changing my PR, get merged without the right reviewer. That's exactly what happens, and it's really fun when it happens on production. But anyway, pull requests with a domino of dependencies. Yeah, pull requests held up due to dependencies on other PRs can create a chain reaction of delays. That's one of the problems when you try to create small PRs, right? Because sometimes you have this goal in mind and you have to implement this feature, and you say, okay, let's create this small PR that will, I don't know, make this tiny change. But then you rely on that tiny change to be merged before you can go ahead with your task, and you can, create the second version, or maybe just add that functionality to whatever. So sometimes this can be a huge problem if you're working on something and you have to say, hey, please approve this stuff, I need a review on that one, and maybe no one review your PR for days. But anyway, this sequential waiting game can be a significant workflow roadblock. Yes, I can feel the pain here. I really can feel the pain. Unfocused improvements. Great pull requests have clarity of purpose. Those PRs that try to tackle multiple problems at once can be confusing, leading to potential oversights during reviews. Yes, each PR must have one focus. You cannot have a PR like improving stuff over the code base. If you want to improve something, just make one single PR. Is easier to be reviewed, is easier to be merged. You will probably have less potential issues. So again, small PRs, small PRs. That's probably one of the best lessons I learned in the last year. The PR with an unattended security risk. Oh, what happens when a PR touches sensitive parts of the code but isn't sent to your security team for review? This oversight could leave applications vulnerable, posing a grave risk to the organization. Yeah, definitely. 8. Pull requests that bypass team experts. Oh, interesting. Every team has its developers responsible for maintaining specific areas of the codebase. PRs that should be reviewed by a domain specialist but aren't missed out on crucial feedback and insights. Okay. 9. The test last. Oh, okay. Code without tests is like launching a boat without knowing if it floats. Yeah. PRs that lack associated tests can lead to undetected bugs, compromising the application's stability. I love this point, and this is probably the easier point to fix, right? Because you just need to tell your team, if you don't attest to your PR, the PR is not gonna be merged. It is so easy. It is so easy. Of course, sometimes don't happens quite often, but happens. You made changes to the application, and that change was kind of already tested before. In that case, just write a message in the PR and say, hey, this stuff was already tested in this file. But in the other 99% of the cases, if you don't add the test or if you don't change the tests, the PR is not gonna be merged. That's it. That's it. Pull requests lacking context. Okay. That's really interesting. Pull requests without an estimated review time or descriptive title can lead reviewers in a lurch. Not knowing the commitments required can lead to delays in picking up their request. Yeah, Let's say that I am changing something big or something related to my business logic or something related to authentication. So something that really requires attention, right, inside the application. In this case, you as a developer should at least say, hey, if you want to review this PR, it's better for you to block, I don't know, half an hour or an hour of your time or something like that. You have to give everyone a little bit of context of what you're doing and how much time, more or less, of course, it's gonna take to review your PR. Else, you just create a PR and it's gonna be stale on on GitHub for days or even weeks. This point is really important for me. One of my last tasks in my last company was to delete a huge legacy piece of code. It took me 2 weeks and something like 12 merge requests or something. So there was a lot of work involved through the entire application stack. It was fun, to be honest, because it's fun when you can just remove a lot of stuff and seeing lines deleted, file deleted, and everything still works very well. But this removing legacy code or not used code, same applies for dependencies in some cases, can be really frustrating. So be cautious, take your time, ask for as many reviews as possible, do as many testing as possible. If you can, try the stuff. Do also, even if I'm not a big fan of it, but do also as much manual Q&A possible on your application, possibly on a different environment. Don't do this stuff on production directly, or at least I wouldn't be comfortable of doing huge code removal directly on production. Of course, if you have a good test suite, you can do it, but just for the peace of mind, I would do it before on task daving. I would do it on staging, test, whatever you call it. So just use another environment if you have this kind of huge legacy code removal. Okay, we are at the end. 2 potential solutions to the toxic PRs. That's interesting. Depending on what side of the development debate you sit on, you may have heard of 2 potential solutions. Pair programming, okay. And what is the second one? Continuous merge. Okay, let's see. So, pair programming. Want to cut out toxic pull requests? You can choose to increase pair programming within your organization, setting up developers to work together on code, with one engineer serving as the driver, while the second serves as the navigator or observer, providing live reviews of the code and switching their roles as needed. So, usually when you do pair programming, you switch roles. Usually, at least for me, was like after 1 hour or so, or after 2 hours, or after a batch of work. So right, we need to implement this, and this today. Okay, let's split the tasks, right? While pair programming increased the person hours needed to deliver software, it has shown positive effects on defects rate in software. Yeah, definitely. However, pair programming can also be challenging to implement on many teams, particularly in instances of remote pair programming. To be honest, I did a lot of remote pair programming. I actually never worked in an office, so I'm like an exception to that. But using remote pair programming, I see that having 2 screens. In the first one, you have the person, so you actually see the person. Of course, always camera open, please. And on the second screen, you have the code. You use live share. You just have your microphone, your headphones, and it's like having the person right in front of you, because you can see it, you can hear it, you can talk with the person. Of course, only live you have the live share session, and the person can drive with you on your same code base. You can share the server so that the other person can try it out on the other machine. So I think that with a good setup, can work really well. I did it for 1 year. It worked so well. I will never come back. Some great advice about pair programming comes from a member of the Dev Interrupted community, Ryan Latta, he recommends. Okay, let's see what he recommends. Have a conversation before you work with your pair. Of course, the conversation should establish the rules, like how often you switch and what's expected of the driver and navigator. Yeah. So clear rules. That's basically it. Next, and of equal importance, is to form some sort of agreement about your working style or preference. Yeah. A great question to ask is, if I see you struggling or making a mistake, when you like me to correct you, and how would you like me to correct you? Yeah, that's really important because sometimes you have different communication styles, or you have just different working and development styles, right? Sometimes you just prefer to deep focus for at least 1 minute in silence without no one talking over you, over your thoughts. And then if you continue to struggle, then you ask, hey, do you saw something that I missed, or whatever. But it really depends on the communication style. Something I noticed is that with some colleagues, based on your personal preferences, is simpler to work in pair programming. Someone just don't like pair programming, or someone has a different communication style or different working style. So just find your fit. And the second one is continuous merge. That's interesting. For many teams looking to streamline their code review workflow, implementing continuous merge can provide major improvements. Yeah. Continuous merge is a process where, upon passing automated tasks and workflow analysis, code changes are seamlessly integrated into the main branch based on programmable rules. Research showed the implementation of Gitstream, a free continuous merge tool. Oh, I didn't know Gitstream. A free continuous merge tool designed to optimize the transition from coding to deployment, improved software delivery cycle by, oh, that's a lot, by 61%, while peer review time improved by 38%. Good. This occurs due to customizable programmable workflow that auto-send reviewers, attached estimated time, reviews time tags to pull request. What is this based on? It's like number of lines changed or files changed, or I don't know. Well, we look into it. Categorize pull requests based on the repository risk, low, medium, hard, or high. I don't get how can be done automatically. I guess there is some kind of rule, but we'll see. Implement an auto-approve feature for low-risk PRs. Create quick policy as code guardrails. That's interesting. I definitely want to take a look at it. How are you solving the pull request problem? The research of pull request is clear. We have identified a crucial bottleneck in the workflow of model software engineering teams. While linear-based team is focusing on development of continuous merge tooling to solve the challenge, organizations are taking a variety of approaches. Okay, so this article was like sponsored by, I would say, from this company, which still looks interesting to me. Yeah, I'm definitely gonna take a look. All right, we saw a lot of potential issues in our PRs, but I think that we saw also a couple of solutions that we can implement easily in our workflows to reduce, the time and also the pain, I would say, of having a lot of PRs, tailing PRs, and so on. So I hope you enjoyed this video. This is one video of the series where I try to learn something and then commenting what I'm learning and trying different approaches and so on. If you liked this video, just drop a comment or a like below, just to let me know that I should continue with this stuff. And still, thanks a lot for watching, and I will see you in the next video.